Memory consists of electronic components that store instructions waiting to be executed by a processor. So whenever your computer receives any instruction, it is loaded in memory. So memory has these three functionalities. It stores, first of all, the operating system, that is when it is open, it is loaded in memory, and whenever you will open any application, it is again loaded in memory, and any data that is being processed and resulting information is also stored in memory until you save that program. So memory usually consists of some chips on the motherboard or any other circuit board in the computer, and so this memory stores data and programs temporarily, not permanently. So whatever you will open, until and unless you save it, it will be stored in memory. So each location in memory has an address, as we discussed earlier. Bits and bytes make up the words or the alphabets. Byte is the basic storage unit in memory. So whenever you have to save something, it is stored as a byte. So every byte has an address. So memory size that we usually measure is in gigabytes or is in terabytes. Um, Computer has two types of memory. One is volatile and the other one is non-volatile memory. So your RAM is also known as main memory. It is volatile memory, and volatile means that it will lose its contents whenever the power is turned off. The moment the electricity is turned off, your adapter is removed, whatever you are doing the work will, if not saved, you will lose that work. So this type of memory is known as volatile memory. For example, your RAM, that is random access memory. So this random access memory consists of those memory chips that can be read from and written to by the processor and other devices. That is, whenever operating system is loaded, it is loaded in RAM. Your programs are loaded in RAM. Your data and application, everything is loaded in RAM. The second type of memory is non-volatile memory, which will not lose the contents even if the power is removed. For example, ROM, flash memory, CMOS. These are those. These are those non-volatile memory that will never be lost. A loss that will never be never fade away. So ROM chips are permanent. So whatever is written there, for example, whenever you turn on your computer, whatever you see that is written, it will be the same forever. It won't be removed. Okay, so let's discuss how your program functions, how it takes instructions in and out of the RAM. So whenever you turn power on to a computer or mobile device, operating system gets loaded into RAM. You see, this is a hard drive. So whenever you turn on the computer, it has a blank screen. So operating system gets loaded into RAM, and the screen will be, now you will see the startup windows, and other programs will be loaded as well. So these files will whenever you will open any file, these files will remain in RAM as long as your computer has power, your mobile has power. So any program that you will be loaded in RAM. You see, this is program 1, this is program 2, and if you will close it, it will be removed from RAM. And until and unless you do not close it, it will be there. And if the power is shut down, you will lose everything from RAM, and RAM will now be empty. RAM is also of two types. One is the dynamic RAM, and also known as DRAM, and the other one is the static RAM, that is SRAM. And these are common DRAM variations. There are variations in this DRAM as well. So SDRAM, DDR, DDR2, DDR3, DDR4, RDRAM. All of these are DRAM variations. These are the generations of RAM built on the previous generation, faster than the previous version of RAM. So don't need to remember every detail of the RAM, but you only need to know that the latest version is obviously faster than the previous version, and it will work good for you. Let's see in detail what these two RAM types of RAMs are, the difference of these two types of RAM. The difference between dynamic RAM and static RAM is that dynamic RAM chips must be re-energized, whereas static RAM chips are faster and more reliable. These chips do not have to be re-energized as often as DRAM chips. Hence, they are more reliable, more expensive, faster, and special applications. That's why I use these SRAM chips, because they do not need to be re-energized. Whereas dynamic RAM that we usually use in our that are usually in our laptops, in our systems, they need to be re-energized, so they are less expensive than static RAM. RAM chips usually reside on a memory slot, a memory module, uh, as we have seen earlier as well. So these are the memory chips in black color, and this is on a memory module. This green one is a memory module, and this memory module is inserted on the memory slot on your motherboard. So these memory slots on the motherboard hold these memory modules, and we have two types of memory modules: SIMs and DIMMs. SIMs is a single inline memory module, and DIMM is the dual inline memory module. So SIM has pins on opposite sides of circuit board, whereas DIMM has pins that connect together to form single set of contacts like this. So this has single set of contacts. So SIM has pins on opposite sides, whereas DIMM has pins on opposite sides of the circuit board. Okay, another form of memory is cache memory. So to speed up the processes of computer, this cache memory is there. Most of today's computer improve their processing times with the help of this cache memory. So this cache memory is actually a temporary storage area. So there are two types of cache memory. One is memory cache and the other is disk cache. So whenever the processor reads an instruction from RAM, you see, as we discussed in the previous that previously, that processor takes instructions from RAM, but before taking from RAM, it checks the cache memory for any instruction. So when the processor needs an instruction or data, it searches memory in this order, that it has to search first the cache memory and then RAM. So cache memory is also of three types: L1 cache memory, L2 cache memory, and then there is another cache memory, that is L3. So when the processor needs an instruction, it will search first of all L1 cache. If it finds it out, then it will do its work. Else it will search in cache memory 2, that is L2. And if it exists, so the faster one is L1, and if it do not find it in L2, then it has to find it in L3, which is a separate chip between processor and RAM, usually not on all the computers today. So if it do not finds it in L3, then it will search it in the RAM. And if a processor cannot find it, that instruction in cache memory and even not in RAM, then it will search a slower speed storage medium, that is hard drive, for that instruction or data. So L1 cache is built directly on processor. So it has a very small capacity, but it is very fast. L2 is slightly slower than L1, but it has a larger capacity. And L3 is on the motherboard, separate from the processor, and it exists on only some of the computers, not all sort of computers. Read-only memory or ROM is the second type of memory, which is non-volatile, and it refers to the memory chips that store permanent data and instructions. So data on these ROM chips cannot be modified. It is non-volatile, which means the contents will never be lost, even if you remove the power. And in addition to computers and mobile devices, some of the peripheral devices also contain these ROM chips. So, manufacturers of ROM chips often record the data instructions or information on the chips whenever they are manufacturing the chips. And these ROM chips, they are known as firmware, which contain permanently written data, instructions, or information. For example, your computers or mobile device startup instructions are written on the ROM chips.